Hi folks, I'm Manas, the Advocate at OpenObserve, and today we are diving into one of our most powerful features, custom charts. This feature allows you to create custom visualizations that exactly fit your data needs. While OpenObserve comes with 19 built-in chart types, but sometimes we need something more specialized or complex which these standard charts cannot provide. This is where custom chart comes in. Custom charts allows you to leverage the full power of Apache ECharts and help you visualize your data exactly the way you want. In this tutorial, we'll focus on creating custom charts from scratch, and we'll also understand how we can map our own data with the chart options. All right, let's dive in. So let me begin with selecting a data source for our custom chart. Let's go to custom charts quickly and let us select our log stream default. Now let's go to Apache eCharts example, and we can pick a simple example as a first example, something which is not available in OpenObserve by default with the built-in chart type. And then maybe later we can also pick any advanced example like these 3D charts. All right, let's go ahead and select this dashed line chart with these symbols, triangle symbols right here. Awesome. So as you can see that at the heart of every custom chart, there is a JavaScript option object. And this JavaScript option object is where we define all our components required for that visualization, including access, series, data, everything. As you can see that here we need at least two dimensions, one to be plotted on the x-axis and another one on the y-axis. Now let's try to replicate this graph or this chart into OpenObserve. I'll go ahead and simply copy this options JavaScript code from this Apache eCharts example and paste it right into my OpenObserve instance. Let's write a custom SQL to get the data we want to visualize. I'll write a simple query like select agent as A. Noticing how I'm aliasing these columns as A and B, this will make them easy to map them into my JavaScript code. Here I've utilized two fields. I have used agent field as our x-axis as column alias A, and count aggregation of the body field as our y-axis, which will plot some numerical values on my y-axis. Now let's look at our chart configurations here. Well, OpenObserve provide us with the query results in our data variable. And let's add a console log here to do some little bit of debug and also see what our data variable looks like. Next, let me also complete this code so we can see what our data structure looks like. All right, now let's hit apply and see what we get. Well, here I have this chart in place where I have these agent fields plotted on my x-axis and some numerical values, which is the count aggregation of the body field on my y-axis. Now let's quickly go to our console tab and understand how we got this chart in place. So I'll click on apply once again to fire this query here. Well, the data variable is an array and data 0 contains the rows from our query results. And why exactly data 0? Because if we are running a single query here, if we were running a union query, then we might have data 0, data 1, and data 2, so on. And each element of this data array containing a result set. All right. So now this data 0 element has rows containing or matching properties from our column aliases as A and B. This is our array or the result array we have. Here we have used this map method. The map method is an built-in JavaScript array method that applies a function to each element of the original array and provides us with a new array. And here when we write data is equals to data 0, map val is equals to val.a, the val parameters represents the each element of the original array. And in our case, each element is this each row here. And when we write val.a, we are extracting just the a property of this complete data array and creating a new array for our x-axis. So when the map method iterates through it, we are just extracting the A property here for our x-axis and similarly the B property here for our y-axis. Well, this is a powerful way to convert our raw SQL data into an format which this chart needs. Here we can see that the map method is quite crucial one because it is responsible on how we transform our raw data, and different chart types expects data in different formats. So you can go ahead and practice this with different chart types. Now we've seen that how we can map our own data with the chart configuration. So let's look at some more configuration options or customization options available here. So we have this type field common to all these three properties, which is x-axis, y-axis, and series. So what is this type field exactly is? Understand, let's quickly go to our documentation once. And here let's look for our x-axis. We'll find type. And in the type, we have four kinds of customizations options here. So we have value, which is suitable for continuous numerical data. We have category, which is suitable for, again, discrete data. And we have time and log, which is respectively suitable for just time series data and some log data. So here we have these four customizations. So let's try modifying our x-axis with something like time maybe. All right. So we have modified the x-axis type here to time. So accordingly, we need to also modify our x-axis field which you have taken, because earlier agent as was a discrete field. It needs something which is of time series type. So we'll do histogram here. Let's do histogram. So we do histogram on the timestamp field of this log record. And let's go ahead and apply. So this modification actually gives us time series on the x-axis. And this way, by changing or adding new properties in this options object, we can change or modify every bit of this custom chart. Here, this symbol is triangle. I can even make this, make it something to like square, and this will change this here. I'll go ahead, click apply. All right, so now this is changed to square. So we can actually customize every bit of this custom chart when we are comfortable with using these options. And ECharts provides some extensive documentation, so you can refer to them wherever needed. Now let's do something advanced. Let's go to our examples once again. We'll scroll down to these 3D charts. Let's do 3D bar. And I'll pick the first one here. So we have this 3D bar with data set. And looking at this options object, this is far more complex than the first one. We have a couple of these customizations and properties. But looking at this chart, what I can infer that we need at least 3 dimensions or 3 fields for this chart. One to be for our x-axis, one for our y-axis, and last one for our z-axis. So we'll go ahead and try to recreate this chart in OpenObserve. We'll begin with copying this option object into our OpenObserve chart editor. I'm copying from line 4 to line 41. And let's go to our chart configuration or the chart editor, and let's paste this here. All right, now let's query some data to be visualized on this 3D chart. Who feels like container? All right, so this query actually retrieves our container name and pod name, and also count the number of instances of the timestamp for this combination. Now let's look at what all we got in our chart configuration here. So looking at this, clearly here we have specified our X, Y, and Z axis. So we'll go ahead and add our own X, Y, and Z axis. For my X axis, I have this container name field. So I'll just pick this from here and add it. All right. Next, we'll look at these axes. So we have our X axis 3D, Y axis 3D. And unlike the 2D ones, we don't need to modify anything here because our fields or these x-axis and y-axis fields are exactly the category type or the discrete ones. So we didn't need to modify anything here, and we can just leave it as it is. For my z-axis, I need to add our dimension from our data. So this will be count. Next, we have our dataset section in which we have a dimensions array and the source data. This dimensions array here, this is a little critical one because it defines the order of the data fields. And we'll look at it how. But let me first complete this code so we can see what our data set or data structure looks like. Let's go ahead and remove this dummy data, add our own fields for these dimensions. Let's modify this data. So we'll do data map val is equals to here. All right. So we've completed this chart configuration. Let's apply. See what we get. I have a 3D chart here where we have the z-axis, y-axis, and x-axis. Now let's do a little bit troubleshooting or debugging, I'll say. Understand what transformation has taken place. So I'll go ahead and add a console log here. I'm gonna JSON stringify them. So basically I'm converting them to JSON strings so that we'll more have like we'll have a clearer picture of the data set. Add one more console log, and this time we'll do it for our modified array. We'll just pick this here. So this is the data array or the data source which is used for this chart. So we'll just paste this here and we'll do and this. All right. So now let's go ahead, open our console tab, dev console, and we'll go ahead and apply again to fire this query. So this array actually specifies our query result. And this is the actual raw data structure which we get from our query. But if we quickly scroll down, and here we can see, so we have these three properties. We have count, we have container name, and pod name. And this is the order we have. But if I quickly scroll down, and from here, so this is the next console log which I've added for our modified array or the transformed data. So if you look closely, order of these properties, container name, pod name, and count, this has changed from our raw data structure or the data array to this array what we have utilized in our chart. So what we have done is that using this map function, map method here, we are iterating on each element of our original array and changing the order of these properties, which is as expected from our dimensions array. So this is the actual requirement here. So the requirement was that the order in the dimensions array should match the order in our data array. And that's why we use the map method here. And this map method converts each object into an array with these three values, which is container name, pod name, and count. And this is the format. The second console log was us that this is the format what this chart expresses data in. And this is a key insight here that with working with custom charts, the different chart types expects data in different formats, and we need to transform our raw SQL query data into the format which this chart expects. And EChart offers hundreds of customization. If you'll go to documentation, you'll find tons of properties available for these options object, and we can modify them each and every bit into our custom charts. Well, once you're satisfied with this chart, you can go ahead, add a name to it, and you can go ahead and click save and add this to our dashboard. Well, to conclude, I can say that the key to effective custom charts is understanding what our raw data structure looks like after firing a SQL query, and also how we transform that raw data into the format which this chart expects. So we utilize this map method sometimes, and if you guys are handy with JavaScript, then you can actually utilize these rich customizations available with eCharts. Well, that is it for this time. Thank you for watching.